Okay, so I called this on doing a maths project with Aristotle. So I think I'll start the presentation right now. I think it's the first time in my career that I've done one just in socks. Well, socks and clothes. And I put Aristotle in quotes because I don't know if it's a registered trademark or what have you. I just don't want you to confuse it with Jackie Kennedy's husband or other Aristotles that you might know. This will be the one from Harmonic. And I made this presentation just for you guys with lots of help. So let me give you some disclaimers here. If you're looking for brand new content, you're not going to find much here. I'll talk a little bit about Aristotle and my experience with it, but frankly, you could probably learn after 30 minutes of experimentation more than I'll be able to tell you in this talk, because there's a lot of good stuff. I'm going to pause for the moment and ask our other speaker if they'll be happy to do a presentation today. Are you going to be the second part of the billing? Yeah. Okay, great. All right, back to the presentation. So nothing really new, just a little bit of polemics there, and I'll try to not seriously inflame anyone. Things are changing, so any particulars I mentioned here about how Aristotle works or anything else, that's going to be out of date soon. So don't really depend on this for updated or eternal information. This that I'm going to talk about, a lot of it is my opinion. This is how I think things should be done. But remember, we're still at the frontier. We're still at the beginning of these things, and no one, to my view, really knows what they're doing because they haven't spent long enough at it. They've got some good ideas, they can follow it, there's some people you should listen to, but no one has the answer, and I definitely do not. And of course, one thing I can guarantee is there will be errors, so questions and corrections are welcome. And again, you're welcome to stop me in the middle of the presentation, but if you ask a question, I'm going to try to make sure I understand it and repeat it for the camera. Now, let's see if I can introduce Aristotle from Harmonic. So I had it here earlier. Come on. So I should go ahead and actually highlight these things a little bit better. Laws of attention. Okay, there we go, Aristotle API. This is Aristotle, the world's most advanced formal reasoning agent, if you believe the press from Harmonic. This is a product of Harmonic, and I get to log in. Come on, there we go.
You're not going to type your password in front of all of us, are you?
Not plain text.
But there's a timing site.
Okay, but you can count the number of characters, and if you've been, yeah.
It's true.
Yeah, well, if there's a camera over here looking at my keyboard, then oh well. Thank goodness it's the password only for this account, and hopefully I got it right. Yay, there we go. Now let's take a look at history. I've actually started working on, with Aristotle 2 or 3 months ago, but as you can tell from the screen, I only just started working on this project about 2 days ago, and it turns out for this task, I've broken it into several steps, and this is one of the key things. If I have any practical advice for you at all regarding Aristotle or using any of these other agents, it's make the steps small, then make them bigger, and then figure out what step size works for you and the agent. Otherwise, it's going to spend a lot of time spinning its wheels, and you will too. Now, let's see if okay, good. So the computer clipboard still remembers stuff. So I can go ahead and introduce you to a few other things, but while I'm talking, we'll go ahead and give it something to chew on. Let me just go ahead and show you, there's some very brief documentation here, some hints as how to use it. If you're interested in the command line interface or in more automatic ways to tie it into your environment, they have that too. My history for this goes back several days, lots and lots of different projects, and all of these are sort of experimental, trying to figure out what the testing is. I strongly encourage you, if just like you're working with a research partner, although you have to be a little bit careful about this. Don't try to tick them off too much, but do test them. Go ahead and see what their capabilities are. And so for this project that I'm interested in now, and that I'm going to talk to you a little bit about later, I've gone ahead and given them several instructions. And this last one here starts, the previous lemmas gave upper bounds, yada, 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 yada. Now, I could spend the next 4 hours talking just about this math project alone, but instead, we're supposed to look at, let's see, what does my slide say? We're supposed to look at some lean code. That's right, that's why we're here. Okay, let's go back and take a look at the lean code. So on this project, I've broken it up into several bits, and I could share the repositories I have here, or I can switch between log mode, which is what it goes ahead and tells me while it's actually working, or code mode. And as you see, I've been keeping it busy for a little while. So let's take just a look at a few lean files that they have there. For example, I've got this thing here called LOA. That stands for Law of Ademption for reasons that only I need to know for right now. And it decided to go ahead and put some of the basic, come on, let's try this again. Hello. All right, we'll try defs then. There we go, defs. Okay, definitions for the laws of ademption. I'm not going to really read it too much here, but I will point out one thing here. It's got a bunch of comments. And in fact, if you're not used to reading the lean code, you'll have a hard time distinguishing between the comments and the actual code. But here's an example of some code. Let's open up some things for some namespaces that we can use. And now let's go ahead and use a namespace for stuff. And now let's go ahead, go down, and let's actually establish a small lemma that we're going to need. Every term of the progression is positive. So that's an example of one bit of lean code. Here's another example.
Are you running lean on this code?
I'm not.
You're going to repeat the question, I think.
That's right. I'm not running, thank you. I'm not running lean on this code. Aristotle is running lean on this code.
So is lean running on Aristotle on harmonic.fund's server?
All of this stuff is being done on the server except for when it reports back to me. So none of this is local. In fact, let me go ahead and add another disclaimer. I used to maintain software and write software in the old days along with my coworkers Brontosaurus and Tyrannosaurus Rex. And most of the time, I basically worked on VI, and that was it. No fancy code editors, none of these tools, none of the big ecosystem that software engineers currently do today. So all the stuff I'm doing, I type it in Notepad, and then I cut and paste in here, or I cut and paste directly into the window, which...
So does it show you the output of running lean on this code?
It doesn't show me the output of running lean. So yeah, it doesn't show me. It does run lean on the code. Does it show me the output? Not directly. What it does do is it gives me a number of reports about what happened when it ran lean on the code. And at some point, I'm going to go ahead and verify it by cutting and pasting it into the lean playground or do something else. But no, Aristotle, I'm trusting Aristotle to do a whole bunch of things to the point that it's now on me to go ahead and verify some of the results. But the point is, I'm asking Aristotle to generate various things. One of them is lean code. We've seen some examples, and right now, I can't tell you that there are any particular problems with it because the last 5 times I ran this experiment, it actually compiled successfully.
Minor question, but does it give you any back pressure or resource usage or indicators right now? I know it's an early product and so on, but whether it's running lean on the remote server or storing Git files for you, is it consuming resources in some way that other people are used to where it says, here's kind of a token counter, and if it doesn't have that, or credits or anything like that? So the question is, what kinds of resource usage reports does it generate? The short answer is I don't know. The long answer is if I went ahead and modified my query to go ahead and ask for this information, it would give me what it could. Okay.
The more interesting thing is I'm not interested in resource usage because this is a free account. I'm just going ahead and using the resources. I'm going in very small steps, and so I'm sort of happy with that.
Yeah, it hasn't been a problem.
It hasn't been a problem.
You
And
haven't
fortunately,
been able to run out of resources so far.
oh, so I haven't run out of resources so far simply because the way I'm proceeding is very slow. All the things that, so I could try to do a massive formalization where I try to get it to think very, very hard about a lot of these things and go ahead and just churn through tokens and do all sorts of stuff. That's not my style. I actually want to do, for my use case, I'm interested in verifying very simple steps that I give the blueprint for, and so that it understands what to do. So I'm not worried about resource usage here. Early on, when I did some of the experiments, I ran into bounds. It couldn't quite finish. I was given the option to complete it or continue it or something like that, and it was reasonably clear about that. But so far, all of the other things that it's done, it says, I'm happy with things. In fact, I'm going to point out something to you right now. Let's see. I'll just read this to you. So I gave it a spec, and it said, sorry, I can't fill the spec. According to my calculations, it's true exactly when this condition holds, k minus j is even. So it actually corrected me. It turned out, yes, I made a mistake because I was typing this stuff in from memory, so I missed a small case. But I said, okay, let's go ahead and deal with that. Okay, so there are lots of wonderful features about Aristotle that I'm really not equipped to tell you about, but I'm happy to share my experiences with you and give you good guesses as to what the answers are to your questions. But what I now want to do, now that we've seen a little bit of lean code and a little bit of the interface, and by the way, they've been changing this interface quite a bit. I don't expect you, if you come back a month from now, I don't expect you to go ahead and see this interface at all. One thing that I think is important to know is that when it's generated code, it usually has an Apache 2.0 license disclaimer up at the top. So my intention is to actually just archive this code and not really use it.
Are they hosted in the US?
Are they hosted in the US? I suspect so. I do not know.
So probably there isn't any copyright on the code. So any license on it is irrelevant because there's no copyright.
So so you're suggesting that the license isn't relevant because they might be running out of the country?
No, because under U.S. copyright law,
Yes.
AI output is not copyrightable.
Oh, so under US copyright law, AI output is not copyrightable. Well, that's cool. Turns out I actually don't really need to use the code except for the following statement. These results have been formalized in Lean and partially verified by the author. For my use case, that's good enough for me. But there are other reasons as well. I want some invalidation of my informal argument. I want a formalization to be established for this stuff that I'm studying and improved upon. So I actually don't think that the formalization, the lean code that I come up with, or the lean code that I modified that Aristotle comes up with, anything like that, I don't expect that to be the end word, final word on the matter. I expect it to be fully changed and modified, so I don't particularly care. What I do care about is that there is a pattern of proof to be reused, and I'll talk a little bit more about what I mean by pattern of proof a little bit later. But in particular, I just want to make sure that I'm not hallucinating myself and that the arguments are actually correct, and that I want to have some base for others to build upon. That's not all. So in addition, I decided to start, especially inspired by some of the work that Rado Kirov did for his Jacobian Challenge project, I decided I wanted some more information that I wanted Aristotle to generate for me, and so I chose these 4 particular things. Explain.md is an attempt by Aristotle to explain what it did, and why, and how. So in addition to whatever lean code that I might have, I have a markdown file that goes ahead and lists the resources used, the MathLab lemmas, the reference to machine accessible and human viewable literature, and so on. I wanted, in addition to that, I wanted a summary. I wanted an overview that I could convince someone to read, because the explanations may go on for as long as the code does, perhaps even longer, but a summary people are willing to read. So I actually wanted an abbreviated version. I wanted applications. I wanted it to use what it knew about the literature to suggest, hey, how could this be used in the future? So I wanted to generate a list of applications for me. And then finally, slides.txt. I wanted an Aristotle-generated version of the summary suitable for conference presentation. Let's go ahead and take a look at that, because that's the most pleasing of this stuff to go ahead and read. So let's go back here. It looks like it's still working with my latest test that I have. Oh yeah, it's way down there. Yeah, Aristotle's working, so I believe it. Code. Let's try prime counting bound. That's nice and simple. There are probably nice ways, really cool ways to go ahead and take this data and download it, but I'm a copy-paste guy, so here's what I'm going to do. Copy, and then let's bring up paste. Except I don't have my LaTeX window up, so we'll switch to that tab. There we go. And let's see if this works this time. Nope. Yeah, no, I need to use something other than a touchpad. I need an actual mouse attached to this thing. So all the tools I like to use are free. So LaTeX I've been using for a while. So now we actually have bounds and prime counting functions. So what I've done is I've broken up the project I have into a bunch of small modules. And for each one, I say I want applications, I want an explanation, I want a summary, and please generate me some slides so that I can go ahead and do this. And this one basically talks about a couple ways to establish a prime counting bound, which is a small part of the project that I'm interested in. Yes?
I would want to congratulate some of our previous presenters on the comparison here. This appears to be the first slide deck that did not get tainted or corrupted by Unicode and or line wrapping and or reference rendering errors between what you thought it was going to be on screen and what showed up.
That's because I asked for TeX format. And that's all it gave me was TeX format, but gave it to me in Beamer, and it knows Beamer better than I do. And one of the things it didn't do, it didn't put its name up there because it was the one that generated it. So I want to make sure that not only did it not do the Unicode or the typographical sins that you're alluding to, but it generated correct Beamer code, and you've just seen it. Let's go back to the slides. Okay, so what else did I want to do in this project? I want to generate these four types of files. What isn't here? Well, there are a bunch of things that could be here that weren't because, well, and I'll tell you why in a little bit, but let me just go ahead and tell you right now. There's no deep dive into the literature covering the background behind the results. There are a few references, a few bibliographic references, which are enough to get you started, but it's not comprehensive, and it doesn't really go or understand the full history. That's okay. That's what I've spent my time doing, and I'll go ahead and I'll write that part up. It doesn't give a record of the motivations for the result and its potential applications. I mean, why am I even spending so much time on this particular thing about prime factors of products of consecutive terms of an arithmetic sequence? Well, there's a reason for it, but it doesn't need to be demonstrated here. I don't have a companion style document with intermediate results and simple consequences for the student to consider. I could generate, in addition to the file, the lean code, the summary, the explanation, I could say, suggest some particular things for me to present alongside this for a person who really wants to study the subject to consider. Simple lemmas or simple results, or hey, if you actually want to see how this is used in action, go look over here. A programmatic style interface allowing reuse of the results by other entities. Well, the idea is that you build mathematics not just to look at the nice abstract structures and the beauty of the particular result you have, and maybe a slightly improved understanding of these artificial constructs you have, you want to use it. You want to go ahead and find other places for it. And if you're going to go into the AI age, you want the AIs to understand it too. And Aristotle should be able to generate an interface that these other AIs can use toward the results. And then finally, well, not finally, but additionally, a laundry list of related but not necessarily equivalent statements from the literature. For example, this thing that I'm working on right now, it basically has to do with members of an arithmetic progression. For those who studied number theory, the first thing you think of with primes and arithmetic progressions is a theorem of Dirichlet, which says every infinite such progression, with a few conditions, has infinitely many primes. This is not that, but it could be related, and there may be a tie into it, and some of the results here might apply to simpler proofs of that. I can ask the AI to go ahead and try to find this for me so that I can help make these connections, develop these connections. Of course, this is a lot to expect of a researcher over a short time frame. I mean, in the past, it's like you prove a result, you write up the result, you send it to your advisor. If they like it, then you go ahead and you try to send it to your friends or your colleagues, and then finally to people that might eventually publish it, and that takes a while. And you might add a little bit more information if, for example, you had to give a talk on it. No one in their right mind would ask for all of these other things.
What version of MathLib is this dependent on? Does it upgrade?
Doesn't really matter, but according to the documents on Aristotle, yeah, the version of MathLib that Aristotle is using is 4.28.
Does it upgrade or did it?
So there may be an upgrade to 4.30, but 3.0 I think still needs some time to stabilize a little bit before we should expect Harmonic to go ahead and incorporate it. 4.28 is good enough for me. And in fact, a lot of these things that, oh dear. Technical difficulties here. I guess I just got too excited. Hopefully the audio is still working. I don't really expect the code to survive a whole bunch of iterations. Something might break. Fortunately, I don't really care because I just want an established beachhead so that people can see the pattern to use, and then they can worry about upgrading it to the latest version of MathLib. That's not my particular concern. But it is a concern if you want to have, quote, production mathematics that survives several iterations of MathLib. But again, this is a lot of stuff here. And as an individual researcher, no one in their right mind would ask for all this, right?
People are definitely asking.
So that was my little bit of polemics there. And now I want to go ahead and turn to the main point, which is mathematics is software engineering. Whether you think of software developers or their CEOs as being in their right minds or not, these things are being done today. They're being done with large-scale platforms involving software development, and the current tools now, the tools that you can access from your laptop over a web interface, you don't need VS Code. It's good to have, and it's good to have your own repository and your own integrated development environment, but frankly, I'm doing all this stuff off the web using Notepad and very little else, just the things that are available. The development and planning has now come to the individual desktop. Aristotle is capable of handling not only the requirements that I showed you that I'm doing for this project, but the ones that I suggested on the previous slide. You can become the professor or the research director. However, if you're to do this, you will need to develop the skills to plan, manage, direct, evaluate, and present the stuff that you're working on. You can't expect the machine to do it for you. The days of just researching and writing a paper are numbered. Instead of doing a math paper, do a maths project, where math isn't how they say math over across the pond. This is bracket S, where you can choose whether it stands for math system, or math software, or math something else. The thing that you work on has now become larger, and that's the point that I want to make for this presentation. Now, it's not all roses. In addition to learning to be a project manager, there will be some concerns, and this is just a partial list. Misformalization is still a danger. You have to be careful that you said the right thing to the program and that it heard you the right way. If you need to, use experts to look over the output, design test cases to go ahead and determine if the theory and the formalization is sound, and use other adversarial techniques to determine how bulletproof the result is. These text-generating machines needed some source somewhere, and because of the way things have been run, we don't know where that source is. There could be a lot of inadvertent plagiarism. There are tools to go ahead and counteract that, but I'm going to suggest a policy of saying, this is the product, the AI did this part, we use these words from the AI. If there's any plagiarism, we're sorry and we'll do our best to correct it and attribute it, but right now we don't know what the source is. So be sure to do that and follow up on the correction. And also, and this I think is fairly important, and this is where I really want people to sort of shift their minds a little bit, is faulty perspective. You will have the machine try to generate analogies to help you understand the subject that you're trying to learn, that you're trying to develop, that you're trying to prove. And it will do its best, but it doesn't know the stuff any better than you do. So it may provide a helpful perspective, but it may also provide a faulty perspective. Don't trust the machine. Try to develop additional perspectives, try to develop additional questions so that you can see how far the analogy goes, where it breaks, and so on. And sometimes the AI can help you with that, but not always. Here are the takeaways. The tools exist now to help with all these things. The tools are still learning, though, how to do them well. You must help them. They won't help themselves. You must help them. The proof artifacts are important to establish existence. There is a correct argument for the thing that I'm asserting. And it's really good, really nice to have that. But the methods and strategies of proof are more important. The actual result, the actual proof, is probably going to be forgotten after its initial use. These methods and strategies should be well designed to be reused. And don't forget testing. If you think you've got a good proof, if you think you've got a good method, if you think you have a good strategy, try to find a way to think about how you can test it to ensure that it will survive under adverse conditions. The communication and understanding of these patterns is just as important, and I say it's even more important than the proofs. So when you can, try to have the AI agent aid you in this. And finally, make it easy to establish relevance and connections. Certainly, I'll go ahead and try to enjoy my particular project as it exists right now, because I'm interested in prime number theory and I'm interested in arithmetic progressions, but really I'm interested in actually bigger things, and I'm going to try to draw those connections and the relevance for that. And you need to make others aware of it if you want people to read your project as well. So there are a few acknowledgments. Thanks to the personnel at MOX for the resources in the venue. Thanks to all of you for actually showing up here and listening to me babble on for a little bit. Special thanks to Rado for his leadership and encouragement. Thanks to Harmonic for the creation, maintenance, and continuing enhancement of Aristotle. And let's see how much work it's actually been able to do while I've been standing up here doing stuff. So let's go away from the code, go back to the log. Hello log. Ran several commands. Aristotle is still working. 711, 716. Ran 7 commands. Okay, so it looks like it's having a little bit of challenge with contrapositive, but we'll give it a few more minutes. And we'll come back to final line of the slides. Yeah, I guess that's all of the acknowledgments. Thank you very much for listening. Did I hear a question? Yes, Boris.
Compare Aristotle to any of the other?
So I've had limited experience.
Repeat the question.
Yes, so I've had limited experience comparing Aristotle to things like Claude and ChatGPT, and I've gotten more hallucinations with them, the other things, than I have with Aristotle. This is why I'm sort of landing with Aristotle, because For my particular goal, which is trying to generate good lean code, it seems to be better. I had bad experiences with the others in the beginning, and I'll probably go back and try them for a few other things just to see, but I'm happy with Aristotle's performance in generating lean code. Did you have a question, Alok?
Yeah, I was gonna ask, how much have you used Aristotle just by like, I don't know, number of chats or something, or some sort of measure?
That's a good question. So how often have I used Aristotle? Not as often as I should. That's the real answer. But if you actually want a number on that,
Not often enough to hit the limits.
we'll go, yeah, and all of these, by the way, have been very small projects. I haven't tried it for auto-formalization or anything like that. So there's this project of 2 days ago, there's this other thing of 3 weeks ago, there are these projects that happen in May, there are these projects that happen in April, quite a bit in April, there's a few in March and a few in February. So I think a total of about, let's call them experiments, about 70 experiments so far. So I've had some experience with it, and I haven't pored over the results. What I've done is I've tried to figure out where it took longer, where it took smaller, should I feed it more information? Basically, it's sort of like a warm-up or a honeymoon period. Just how can I get it to work with it in a way that I'm comfortable with? I've verified the code for some of these, not all of them, and I haven't spent a lot of time worrying about its output. I've worried more about the interaction and whether I trust whether it makes sense to me. When I have to go ahead and nail down and convince someone else of it, then I'll go through and I'll put the microscope on it. But for right now, its performance has been very satisfactory for me. Other questions? Yes.
So regarding your point about understanding or communicating the proof being as important or more important than the proof artifact itself, I was wondering, do you think that is something that will ever be fully automated in the sense of maybe we find some heuristics that collectively, if you give it to the model, it's able to basically provide you with a very high quality explanatory proof? Or do you think that's something that humans will always have to kind of guide the direction of how things are communicated?
Okay, so let me make sure that I understand the question. Do I think AI will be able to give a fully satisfactory explanation for things, or do I think it will always have to be human guided? Well, you know what? Let's ask Aristotle. Let's see, where should I go? Let's see how it did on the project that I've been working on today. We have code. So since this is a little bit quicker view, let's go ahead and do summary law of ademption. This project formally verifies in Lean 4 a basic result on arithmetic progressions, yada, yada, yada. So the object of study, fixed natural numbers, yada. We're going to do this arithmetic progression, yada. When d equal 1, these are the consecutive integers, great. For the exact power of p, we're going to go ahead and define this. The basic result, one idea, phrased 2 ways. Valuation form, divisibility form. Now, the style's a little bit stilted. I could probably choose slightly different words. It's not pedagogically up to it, but this is a really good foundation to start. So I'd say today, it can help you make that presentation. Will it do it all by itself? If you want to read it, probably it's better for you to look at it, say, I've got this information from Aristotle, here's my take on it. And so you go ahead and you add particular notes to it. Yes?
One quick follow-up. Do you think there's some formal theory of understanding or of explainability / pedagogical legibility? Is there something formal underlying that? Or is it more just kind of like a vibes thing?
So I've run a couple projects. One of them was called SCS 2022, and it was in conjunction with the virtual ICM that happened there. And one of the goals there was studying short communications. I reran that experiment again, and I'll publish the results of that. But the idea is that there are several theories of presentation and pedagogy that can be used, and there's a lot of them could be competing. A lot of them might be marginally successful, but the fact is, lots of people will learn the way they want. So I don't think there's be one that fits all. But there are ways to go ahead and not just use the theory, but use the tactics, use some strategies, and do things to improve the communication and improve the presentation. And that's part of the reason why I want to go ahead and do CSC 2026, is to go ahead and continue that experiment. So personally, I believe there are lots of theories, and yes, improvement can be made, and yes, AI can help. There was a question over here. Yes, Rado.
Sounded like this is your mathematical research and used Aristotle kind of as a verifier with Lean, right? Have you tried using Aristotle as a generator of new ideas and kind of more of a collaborator on a higher level?
Yes, I have. And in fact, I had Aristotle actually look at an old problem to see about its collaborative possibilities. That came up, actually Claude also did too, but it came up with something very clever. I had a result that used continued fractions, and I like it. It's a nice result. I'm proud of it. It came up with a different continued fraction for the same thing that I think is worthy of study. So it definitely has the potential to suggest things.
Did you do it just in text, or did it with Lean too? Or
so it generated Lean code too. I actually went through the Lean code, and
if you're just talking to Claude, it would not do Lean, right? And that's something unique to think
actually I'm maybe getting these confused, but I actually had Claude generate some Lean code for me too, but on a different project. And again, I was still experimenting with Claude, and it kept trying to say, oh, this would compile except for this thing, except we need to change that. Oh, wait, that didn't quite work. Now we have to change this as well. I only had like 3 sessions of that before I said, I'm going back to this thing.
A lot of people are experimenting with LLMs without verification with Lean. That sometimes creates some results, but often it can create this experience of it's incorrect.
Yeah, so again, in the early days, where early days means 3 months ago, there were problems with LLMs with a lot of hallucinations, a lot of incorrect results, and so on, and I've been there too. But Aristotle was very good even back then. The others are getting a little bit better, or at least they're getting a little bit more reserved and saying, I think this is right, and so I'm starting to trust them a little bit more. But I'm going to recommend that if you want to do mathematics, then, or even if you want to do software verification or a number of other things, you should give Aristotle a try. But in particular, Aristotle is being developed for the use of developing mathematics. I think it's there. I think you can use it today to develop mathematics as well as verify arguments. Did you have a question, Elliot?
No.
Okay. Any other questions? Yes, Perry.
I came in a little late. And
Yeah?
I wondered if you could maybe repeat the mathematical content that you were investigating.
Almost none, because I want to talk about Aristotle and Lean more than I want to talk about, well, actually, no. I want to talk about mathematics more than Aristotle and Lean. Mm-hmm. This presentation has very little mathematical content. Now, if you want, we can go ahead and say, hey, let's look at Sylvester Schur, and I can show you all the fun things you can do with that, but that wasn't the point of this talk.
I don't know.
We have another speaker, so yeah.
Yeah, we have another speaker, so I'll be happy to do it.
I think I heard one thing. Would you be willing to share some of this? I see there's a share button after the talk.
Okay.
Some project, I don't know which one, but people might be interested to explore.
So I actually want to go ahead curate some of this, because this stuff I just started generating today, I've looked through it and I'm happy with it at a very superficial level. I've done no deep dive in it.
After the talk or something.
Okay, so I'm happy to provide you some of the earlier experiments, and when I think this is good enough to share, I'll be happy to share this too. But I'll go ahead and share a few other things that are a little bit smaller scale. But again, I don't think you actually need the example of the explain file and the summary file and the slides file and the applications file. You just need to know it's possible. And I'll be happy to share the prompts of that if you think you need some help with generating the prompts. That's fairly simple. It's just, I want this for this reason with these properties. And you should be able to come up and have it generate something to your pleasure. Any other questions? once again, thank you very much for attending, and I think we have our next speaker coming up.